So this is main shut-offs, main turn-on. This enters through this 2-inch line, comes right into these descaling devices. This valve right here is a bypass, so if these ever were to fail, you can shut those off to repair them, turn this on so the water to the building doesn't get lost. And then it just runs off and that heads right over to the booster pump through this 4-inch copper water line.
Right here.
So we're in the storage room for the maintenance department across from the fire pump room. And this goes to an outside frost-proof faucet. If we shut that 3/4 line off and open up the valve, come September, it'll drain itself out. That way we don't have any burst pipes down here. That's the outside spigot we just went over in the maintenance room. Just for gonna undermine this ground. We're gonna put a 3/4 copper water line in, and we're gonna run it right over to this wall. There's gonna be an outside spigot out here, and then there'll be a shut off and a drain point inside the building later on once we get to it. So on the existing copper, we connect into it. We come down, we tie into this booster pump. I highly recommend just to look at the owner's manuals for resetting the system. And then once we come out, we're at like 125 psi, but we have our pressure reducers through the mains. And then it just feeds back through here, heads up, and then feeds the rest of the building. So whenever it rains, the rainwater comes down and enters this trench drain. We'll have to keep the debris, leaves of any sort free and clean from it. From this trench drain, it goes underground over to a just like a storage tank, which then enters this storage tank and then enters the pump chamber and pumps out right into the street. Enters this pump chamber, and these two pumps, this is the main pump, that's the backup pump. They go up and feed right into the storm drain system and exits the building. This is a hydro accumulator tank. Because it's a high rise, they need this on the system because there's so much back pressure up 20 stories down. This basically just holds back on that pressure of the building. That outside water faucet is going to be going out through there. So I'm going to have a drain set up so we can shut it off outside, and it's going to be pitching back into the building. So we can just turn a valve on, unscrew the bottom cap, and drain it out nicely. And then this is the backflow, so no rainwater or anything sucks back into the building for contamination. This is the floor drain for the women's bathroom on the first floor. It's out in the open. There is a change order that's going to get all insulated and heat traced. Right under here, there's some screws. There's 2 or 4 screws. This pops right out, and there's a filter. You just unscrew it. It should be like a 1/4 turn. Pops out, and then a new one pops right in. Yeah. And then put this back right up.
They both have them?
So that one does both? One. Just awesome. One. The water goes through that filter and then feeds both of them.
Oh, where'd you get that awesome bottle? Is this a light?
They give these out.
All right.
Not everybody got one though.
Rob, no, drink it. Now you're gonna drink it. Let me see you drink it.
Yeah, right up here there's 2.5-inch lines and a 1-inch line. The 1-inch is the hot water return. The 2.5-inch lines come in and they feed this whole kitchen. And in case of a catastrophe happens, just go to those and shut them off if anything pops in the ceiling or anything like that. So these are the hot and cold backflow preventer, so that no chemicals get siphoned through the dishwasher back upstream and contaminate the water for the building, so no harm comes to anybody.
These are the first 2 of 5 in the building.
Yes.
Okay.
That trap primer goes to these 2 floor drains, just so there's no sanitary smells coming back up through the drains. We're on the first floor women's bathroom. In this access panel, we have a trap primer ball valve that feeds some of the floor drains in the kitchen and the floor drain for the actual women's bathroom. This is your standard toilet. On this valve, there's a red light sensor. It needs some solar power from the light. If not, it does have a manual flush on it. If you pop this cap, there's a screwdriver valve, just screw it shut in case you ever need to work on it. So these are the return valves for the lower floors. Each individual stack has its own individual shut-off in the hallways. So this enters the 9th floor, heads all the way down to the ground floor, comes back out and returns the hot water all the way up to the penthouse through these lines.
Why do we put balancing valves?
Just so every unit gets equal hot water. That way. So this is the domestic hot water pressure reducing valve. This feeds from the 9th floor down. It lowers the pressure down to 40 psi for each unit.
Came up with 40.
The engineer. So it was specified for 40, so that's what we put it on.
You actually raised it to 50, right?
Yeah, we have it at like 50.
I was gonna say, you think they put
58.
about 50.
Yeah.
It
It was originally at 40 and they raised it to 50.
Because 40 is too low,
That's
right?
how, that was the pressure cavitation, because it wasn't getting enough pressure. It stopped around, the 17th floor, so the pump would just siphon itself out and then lock itself out, so nobody get hot water. This is the master mixer for the entire building, the brain. This is the set point for the return water coming in and the hot water going out. This is so it doesn't exceed the 130 state regulation of the plumbing code. We have the domestic cold water coming in on one side and the domestic hot water coming in from the water tanks. And then this is the main feed to the entire building. These boilers control the temperature of the tanks. Here's a master shut-off for it, for the domestic cold. And this is the bypass system. If anything were to happen, you can't get hot water, turn this valve on and turn this valve off. And the building will continue to get hot water. This is the lower flow pump that goes 1 through 9. It's the recirc pump for the entire first floor through the 9th floor. And this is the recirc pump for floors 10 through 19.
Why does that look so much smaller than the other one?
This one needs a lot more head pressure to get all the way up here. This one is it's a decent sized Tyco, and that's all it called for the engineering specifications. So we have our domestic cold water inlet and our domestic hot water outlet. There's about 2 gallons of water of ours in these tanks. The rest of them are the heat lines that the boiler feeds. So the boiler hot water feeds. It heats up our coil, and then it exits and returns back to the boiler. This air scoops, the heat guide system, that's for the boiler system. The TMP valve, that's for the boiler system as well. So when that blows off, the boilers are actually running too hot, and that's making it blow off. So our hot water will never exceed the temperature that the boiler is feeding us. And it all has all shut-offs, 1, 2, 3, 4, and they all have unions on them, 1, 2, 3, 4, for maintenance and replacement. To bleed the system out properly, this is to the lower floor pump. Shut this system off. This is to the upper floor pump. Flip that switch off. And then you come over here to these 2 valves. This is the return to the mixing valve. You turn the main feed off and you open the side port. Once that's open, shut the upper valve off, or whichever floor you're bleeding. Say you're bleeding the lower floors, you keep that one on, and then you turn it on. That way that pump will flow right to a floor drain, and if there's any air in the system, it'll blast out through there, and it won't damage the pump. And then vice versa, if you want to do the upper floor pump, turn this off, turn this valve off, reopen this valve, keep those valves the same, and then turn that upper pump off, and that will drain into the floor as well. And if there's any air holding it from hot water getting into the system, it'll flow the air right out. And then to return it on, just open the lower floor pump on and turn the lower floor pump right on, and they should all be aired out. This is a boiler shut off to the natural gas. If any of these got damaged and needed to be repaired, they can shut it off right through this valve. Each one has its own individual 4-inch gas cock. And then the cogen system has its own 2.5-inch gas up in the air. And that will shut off the cogen system in case of any failures on that. This is a backflow system to the chillers. It just connects our water lines so they can feed the chiller tank, just so none of the heat lines can back siphon into the domestic cold water system. This is another backflow. This is to the boiler feed. When the low water cutoff comes in, they hook a hose up to this and they refeed the boiler system so it turns the hot water back on. Up from here to here.
So you backfed it?
Yeah, so we backfed our domestic hot water, domestic cold water into the boiler system until that gauge reached 20 pounds. We're on the 19th floor. We have a cold water feed. This goes over to the trash room where there's 2 chemical tanks that this water goes through, and once you spray down the trash chutes, it takes off all the debris. It's just the 5th backflow of the building, so they can know when they come to test them, they know what part of the building it's in, and it's in the mop sink room. And I'll show you the chemical tanks. This line enters, and it takes soap through this chemical tank, and then whichever wash down you want to use, it opens up. It cleans both. We're on the 2nd floor laundry room. Right behind this first wash machine, there's an access panel that has all the water shut-off valves to it. There's also a valve for a trap primer in here for that floor drain. Right here, there's also another drain clean out. If this stack ever gets clogged, we can move this out of the way, pull the clean out and snake it from there. There's also another clean out right up top here, and another clean out right behind here. So there's 3 clean outs. There's also the main gas shut-off valve for these gas dryers right here in this access panel. That'll shut off these 6 gas dryers. This is a typical bathroom. In every single bathroom there's an access panel right above the toilet. That'll have your hot and cold water shutoffs per each toilet, kitchen sink, and lap sink. And then in every shower there's also another access panel. That's to get at all the electrical, and there's a duct fan in there as well. That's just for replacement of that. And then this is your typical shower. Underneath this threshold, you can pop this threshold off. It's only silicone on there. And there's an epoxy rubber strip just in case somebody with a wheelchair needs to get into a unit.
Right, is that all?